Hey Algebras, here's a real quick key to your Unit 6 review packet. So hopefully you've already done the work and you're ready to just check your work with mine. Alright, we keep talking about how the biggest skill that you need to know how to do in all of this is to be able to factor. When you know how to factor, breaking a problem down like this is no big deal. So 2x plus 11x minus 6 breaks down into these two factors. Here's the difference of two perfect squares. My x plus 6's cancel out, and that's the answer that I'm left with. Same with number 2. I look here, and I recognize the GCF of 4x. When I take that out and I factor this, I see my x minus 1's can cancel, and then there I have 4x over x plus 3. Working down to numbers 3 and 4, I see a GCF here in 3 and 12. That's going to give me x squared minus 4. And I know right away x squared does factor into x plus 2, x minus 2. But I look at the rest of my problem, and I don't think those factors are going to help me at all, which is why I never factored this one. Here I have SOAP, same, opposite, always positive, because I have the difference of two perfect cubes. So here's my same sign, opposite, always positive, and there I found what I needed to cancel out when I took this GCF. So this one problem has a little bit of everything. It has SOAP, it has difference of squares, it has GCF, and that's how I end up canceling out what I do. So for number 4, we start looking at this division sign, and I recognize that this fraction is going to stay the same, but these two signs are inverses, which is why I need to multiply by the reciprocal or do your keep, change, flip. 2x comes out of this as a GCF. X squared minus 9x plus 8 factors into these two factors, and I can right away cancel out my x minus 8. My 5 is a GCF, and it comes out here, and that's going to give me my x minus 1's that cancel out, and my 2x's cancel out. So when I look back through, all I'm left with is 5 as a final answer. All right, let's take a look at 5 and 6. I'm going to go ahead and I'm going to never divide fractions. Instead, I'm going to keep the first the same, change the sign, and then flip that fraction. I put a 1 under here because that makes it easier for me to remember when I'm flipping to make sure that this x plus 2 ends up in the denominator. This is an 11. I don't know if you can see that, but that factors into x minus 11, x plus 2. Here's my x minus 11's that cancel out because here's the difference of two perfect squares. And I just multiply across. Multiplying fractions is no problem. Top times top, bottom times bottom. And that's how I got 1 over x plus 11. Alright, so make sure you're looking at your signs with each of these. Here we were multiplying, so we can just multiply across, cancel out common factors. Here we were dividing, keep, change, flip, keep, change, flip. Here we're adding, so these have to be common denominators. So 8 plus 7 is 15, and I simplify my fraction, and I'm good to go. Alright, let's take a look at the next page. So we start getting a little bit more complicated here. When I look at my denominators, I have x plus 2 and x minus 1. So I have to give everybody what they need in order to create a common denominator. So I multiplied this fraction by x minus 1 over x minus 1. I multiply this fraction by x plus 2 over x plus 2. once I have my common denominator, I can add my numerators only. 4 times this. And remember, we go ahead and say change subtraction to addition and add the opposite. Negative 2x minus 4. I distribute this 4. So I have 4x minus 4 minus 2x minus 4 all over that same denominator. When I combine like terms, I was really hoping I could factor my 2 out and cancel something, but it didn't work for me. You let me know if it worked out differently for you. I was disappointed in this one. I wanted that one to work out. All right, first off, factor my common denominator, because I'm adding, has to have an x minus 3 and an x minus 7. This guy doesn't have an x minus 7, so we have to give it to him. X minus 7 over x minus 7 multiplied to the second term. This one already has a common denominator, no change for that fraction. Once I have my common denominator, I can combine my numerators. 3x minus 2 plus, and I went ahead and FOILed this. X times x is x squared. Negative 7x positive 5x gives me negative 2x minus 35. And I went ahead and combined like terms. Here's my x squared. Positive 3, negative 2x's. Positive 1x. Negative 2, negative 35, negative 37. Again, I was hoping this would factor and give me something else to cancel out. I didn't see it. Let me know if I missed something. All right, let's look at 9 and 10. So I have a complex fraction, and I have to take care of this addition and this subtraction sign first. Common denominator, so just look at your numerators first. Common denominator, I gave this one, they each needed an x. So it becomes x plus 3 over x. This one, I gave them each an x squared. So it becomes 2x squared minus 5 over x squared. Now I'm ready to kick the fraction over. X plus 3 over x divided by, and then it becomes a keep change flip. We don't divide fractions, we multiply by the reciprocal. So now I have my x and my x squared. I can cancel one of those x's out. I didn't get a whole lot else out of it. X times x plus 3 over 2x minus 5. Now, when you're taking a quiz or a test, be ready. If you left that as, oops, that's an x. If you left that as x times x plus 3 over 2x squared minus 5, that would be okay. That's a good answer too. You don't have to worry about that. This is the better answer because it's simplified. That's okay. Complex fraction. Nothing to work out here. I don't have any plus signs that I have to add my fractions. Take a look at the difference between these two denominators. See this plus sign in the middle? I don't have that. I just have one fraction. I do have some work to do here. So this fraction just hangs out and stays the same. This guy, he has an x plus 2, he has an x. So I give him the x, and I give him the x plus 2. You can see those fractions. Go ahead and I simplify that. Combine my like terms, and that gives me 3 x's. So then I rewrite my fraction, 2 over x plus 2 divided by. This divided by is the same as this divided by. 3x plus 4. And there was my common denominator. So here I go. I'm going to keep, change, flip. So this fraction stays the same. This changes to multiplication. And then this fraction flips. Now I can start doing some canceling out. X plus 2's can cancel out. And that's it. 2 times x is 2x over 3x plus 4. All right, for 11 and 12, we start getting into solving, and the whole idea with solving is always make sure that you find a common denominator. If you have these two fractions with a common denominator, then you can just eliminate the fractions. Now, if you want to know why that works, do you remember in Algebra 1 where you had cross products and you had to multiply your values? Take a look at that, and that's exactly why that works. So I have x minus 3 times 3x plus 7. I have 2x times 8 is 16x. So whether you do it common denominator way and then just eliminate your denominators, or whether you do cross products, you get the same answer. Now you've got some work to do here when it comes to solving for x, because here I have to do some FOILing. And then I have to combine like terms. I end up with a quadratic. I factor out my 3. Because I can divide each side by 3, he goes away. I factor this quadratic, and I get positive 7 and negative 1. I have to now go back into my denominators. Are either of those going to give me 0? Are they poison numbers? They're not. So they work out okay. Let's take a look here at 12. I need to factor this first, put this 7 over a 1, and deal with all my common denominators. This guy needed an x plus 2. This guy didn't need anything. And this guy needed both, the x plus 2 and the x minus 2. So once I have a common denominator here, I can add these fractions. Now, I kind of cheated here. I put my sum difference pattern back into my difference of two perfect squares, because I know when it's time to cancel out that denominator and set the numerators equal to each other, I'm going to have to continue to do some work. So I distributed my 7. 7x squared minus 28. And then it's about combining like terms. I subtract 5x squared from each side. Subtract 10x from each side. Factor out a 2. And once I can divide each side by 2, it goes away. I factored, and I got these values for x, and then I checked them in my numerator. 6 and negative 1 are not going to give me zeros, so I'm good to go. All right, so let's take a look at 13. Check it out. It's a gift. Our numerators already match, so we can just eliminate them. My denominators match. We can eliminate them. X squared plus 2x plus 2. Combine like terms, difference of squares. I get two values, 1 and negative 1. 1 cannot be an answer because if I plugged that in for x, I'd get 0 in the denominator. So this is an extraneous solution. I don't include it. Our next one, find a common denominator. And once I have that common denominator, cross it off. Set my numerators equal to each other. Solve, factor, check. Both of these solutions, 5 and 2, are good. All right, so 15 was on your quiz for this week. Here's a hint. 16 was on your quiz for this week. There's a hint. 17 was on your quiz for this week. There's a hint. 18 was on your quiz for this week. There's a hint. 19 was on your quiz for this week. There's a hint. 20 was on your quiz for this week. And there's a hint. Real quick reminder about graphing. So when we graph these crazy guys, always go ahead and plug it into Desmos or your calculator, because that'll show you a picture of your graph and help you figure out the different characteristics. Our horizontal asymptote happens at y is equal to 0 because I have more x's in the denominator. So think about it, that's just like our parent function where we have y is equal to 0. More x's in the denominator, there's the equation of our horizontal asymptote. Our vertical asymptote happens where my denominator equals 0. So I set my denominator equal to 0 and I solve. That's giving me the Poisson number. That's telling me no input value can be equal to 4. When I talk about my domain, all the values from negative infinity up to but not including 4 hop over, and then from 4 on. When I talk about my range, all my values from negative infinity, not including 0, hop over it, and on you go. There are no zeros. You're never going to get an output of 0 because that's my horizontal asymptote. And my y-intercept happens when I plug 0 in for x, and I get positive 3/4. As x gets super, super, super small, I approach my horizontal asymptote. As x gets super, super, super big, I approach my horizontal asymptote. Last up, I have the same number of x's in my numerator and denominator, so my horizontal asymptote is going to be the fraction created by the coefficients. My vertical asymptote is where my denominator is equal to 0. So I set x plus 3 equal to 0 and solve for x. There they are. My domain and ranges are my set of all input values for a domain, hopping over the asymptote. My range is my output values, hopping over the asymptote. My y-intercept is where I plug 0 in for x, and I can see I get a 1/3 out. My x-intercepts is when my numerator is equal to 0. So I set my numerator equal to 0, and that's what gives me my x-intercept. Again, as x gets super, super, super big or super, super, super small, where's the graph going? Always running into and reaching out for and approaching your horizontal asymptote. All right, I hope you feel good about the test. Thanks for watching. Good luck.